Hi, welcome back. We're up to lecture 14, and the topic of today's lecture is mediation. So in the last lecture we covered moderation, but today we're going to talk about a slightly different multivariate approach called mediation. And again, it's important to keep these two types of analyses distinct. So today's lecture is split into just two segments. In the first segment, I'll show you a mediation analysis from what's considered the standard approach. And that's via a series of multiple regressions. And that's why I'm covering mediation here under the umbrella of the topic of multiple regression. But in the second segment, I'll show you how a mediation analysis could be conducted as what's called a path analysis, which is a sort of different approach to the data, and it falls under a different mathematical framework called structural equation modeling, rather than the general linear model. Structural equation modeling is a topic that's sort of beyond the scope of an introductory stats course, so I'm not covering that in detail here, but mediation provides me with an opportunity to give you a glimpse of structural equation modeling and how powerful a tool it can be. I'll save that though for the second segment. So first, let's take the standard approach to mediation. So remember, it's very important to keep mediation and moderation clear and distinct in your head. They sound alike, but they're very different kinds of analyses used to address very different types of questions. So in the last lecture, in 13, we covered moderation. Today, in 14, we'll cover mediation. And then in the next lab, lab 7, I'll show you how to do both of them in R. And again, it's not that difficult to do in R because it's just a series, in both cases, it's just a series of multiple regression analyses. So mainly the LM function, a few other functions, but mainly LM. So remember, again, this little graphic to remind you the difference between mediation and moderation. The mediator variable, or mediation, is designed to sort of account for or explain the relationship between a predictor and an outcome, or an independent variable and a dependent variable, generically just x and y. So let's go back to our example that we used for moderation. I'm gonna provide a slight twist on this example. So X is still going to be an experimental manipulation, stereotype threat. Y is still going to be an outcome, so score on an IQ test. But now let's use working memory capacity as a mediator rather than a moderator. So in the last lecture we looked at working memory capacity as a moderator under the hypothesis that people with greater working memory capacity might be able to withstand or buffer themselves from the effect of stereotype threat. This is a very different kind of hypothesis. Now we're saying, well, why does stereotype threat influence IQ? What is the mechanism through which that threat manipulation works? Well, it may be working memory capacity, and there's actually literature to support this in social and cognitive psychology. That is, what a threat manipulation does is it disrupts people who are under threat, they become distracted, and their working memory is therefore less efficient. So threat, it influences working memory capacity, which in turn influences IQ performance. In this case, it's the mediator. In other words, it's the mechanism through which the effect occurs. So to be clear, this is a formal definition. A mediation analysis is typically conducted to better understand the observed effect of an independent variable on a dependent variable, as in this case with experimental research, or it's also used, and used often, in correlational research to better understand a correlation between X and Y. And that's really where mediation is powerful because remember, one of the problems or limitations with correlational research is correlation does not imply causation. So it's very difficult to get at mechanisms underlying correlations. Mediation is one tool to do that. So if we have a correlation between x and y, we could introduce a mediator variable to see if it can account for that relationship, which might lead us to stronger claims about causality. We still have to be careful with purely correlational research, though. So remember, if two variables are correlated, x and y, then we can do regression. We can use scores on x to predict scores on y. If they're correlated because of the mediator, so if working memory capacity is the mechanism through which this effect is occurring or is working, then the threat manipulation x should predict m, and in turn m should predict y. So we can run both of these regression equations. First, the mediator predicting y, and second, x predicting the mediator. And then finally, put both the mediator and the predictor x into one equation and see what happens to the original predictor x. Does that predictor remain significant and strong? If so, then the mediator probably isn't doing anything. But if when we put in the mediator, the original effect, the direct effect, say of stereotype threat on IQ, if that suddenly goes away, that means it's explained by the mediator. So the important thing to watch here is what happens to the regression coefficient for x after we add in the mediator. Does it drop or does it remain the same? If it drops, that means we have mediation. If it remains the same, that means we probably don't have mediation. So again, a mediator variable accounts for some or all of the relationship between x and y. I say some or all because both are possible, right? So it could account for all the variance between x and y, in which case we call that full mediation. In that situation, you would see the regression coefficient for x drop all the way to 0. But it's also possible that it will just account for some of the variance. So you'll see a drop in the regression coefficient associated with x. But you won't see it drop all the way to 0, and it might remain significant. So there are two possibilities. Well, actually, there's three, right? There's also no effect, no mediation. Just again, a final caution, if you're dealing with purely correlational data, in the example I'm showing you, we're not, right? We're doing a real experiment. We're manipulating stereotype threat. Mediation is used a lot, particularly in psychology, with purely correlational data, and people start to slip and think that they're getting stronger claims about causality simply because they've developed sort of a chain reaction of events. So x is correlated with the mediator, and the mediator is correlated with y, so it might look like a causal chain. But if it's purely correlational and cross-sectional, that is not conducted over time, then you still can't make strong causal claims from mediation. So be careful, especially as consumers of statistics. People often slip and make that mistake. I like to make the distinction between statistical mediation, which is what we'll see here, and true causal mediation. Okay, so how do we actually do this? It's actually pretty simple. In the standard approach, we're just going to conduct 3 regression analyses. So we're going to use that LM function, linear model, again in R. The first one is obvious. We want to predict the outcome variable from the predictor variable. So just y tilde x. So there has to be some effect in the first place for us to find a mediator for. If there's no effect, then we wouldn't be doing this in the first place. The next model we'll run is predicting the mediator from x. So again, think of the causal chain from x to m to y. There has to be a relationship between m and x. Then finally, what we'll do is we'll put both predictors in the equation, x and m, predicting the outcome y, and we'll see what happens to the regression coefficient associated with x. So for mediation to occur, obviously, as I said, we're going to need a significant regression coefficient in that first analysis. We're going to need a significant regression coefficient in the second. And then in the third, again, the critical question is what happens to the regression coefficient for x. So again, back to the example, I'm going to put in stereotype threat as our predictor. And in this case, I'm just going to keep it simple. We're just going to have two levels of x. So a threat condition and a control condition. Again, this is a true randomized controlled experiment. So imagine that students come into a lab and they're randomly assigned to either a threat condition or a control condition. And then they're asked to take a working memory test and an IQ test. So this is an outline of what I call the simulated experiment. We haven't actually done this yet. There's a graduate student in my lab who's doing something like this. So I'll actually have real data, but this is all simulated. But let's imagine that they were randomly assigned to threat or control, and then they completed the working memory task and the IQ test. Importantly, because in the last lecture we covered moderation, here the students are performing the working memory test after the threat manipulation. So it's assumed that the threat effect will also affect working memory performance, whereas in the previous examples, we were measuring working memory before the threat. Okay, so here are the results from an analysis I conducted in R. And the font's a little bit small, so we'll have to zoom in on that. And there's parts of this I'm going to save for the second segment. But the main piece of this to look at now is right above this line. So R is really nice. It has a function built in that runs all three of those regression analyses in one step. So you don't have to write 3 lines of code. You can just write 1 line of code indicating what's the predictor, what's the mediator, what's the outcome. So we did that, and we'll cover this in the next lab, lab 7. So what you see is, unfortunately, R's output orders them a little bit differently than I ordered them. But the first one is the same. So we're predicting the outcome variable, y, from x. And here are the regression coefficients. And what you see is the predicted score on IQ when in the control condition, because when x is 0, right, is 97. So that's about average. Remember from the last lecture, this IQ score is scaled to have an average of 100. So it's about average. The regression coefficient associated with x, which is stereotype threat, is -11. Why is it -11? Well, because we coded control as 0 and threat as 1. So a 1-unit increase means going from control to threat, which is associated with an 11-point drop in IQ. So this looks like the threat effect, or that threat manipulation is working. It's pretty strong. All right, so if you look at the t-value, it's -3.75, and the p-value is really low. So there's clearly a threat effect. Again, we made up the data, so we made it strong. So that's the first one. The second one is down here. We want to make sure that the threat effect, or sorry, the threat manipulation is also having an effect on working memory, and indeed it does. Similar magnitude, in fact. So the predicted score for working memory in the control condition is 54.92. Remember, this variable is measured on a scale of 0 to 100, so again, that's about average. But then again, there's an 11-point drop in working memory for people in the threat condition, and that's a pretty strong effect. But what about the mediation effect? Well, that's right here in the middle. Remember, the critical question is what happens to the regression coefficient associated with X, that is associated with the threat manipulation. Well, that's right here. It's -2. And the t-value is right here. It's only a -1. And the p-value, it's hard to see because I wrote over it, is 0.3. So it's no longer significant. So that really strong and significant effect of threat on IQ is now no longer significant because we added working memory into the model, and working memory is also impacted by threat. So this looks like full mediation. To show the results a slightly different way, I also plotted some scatter plots to show you just the relationship between working memory and IQ in both the control and threat groups. And what you'll see is that there's a relationship in both conditions, right? Because the variance accounted for was the same, so this should hold. It's a little difficult to see because I put them on different scales, so let me sort of note this for you. You saw it in the R results, but let me highlight it on the graph. An average IQ is around 80 here. And note that over here, that's down here. They're not on the same scale. Should fix that. So that's where you're seeing the threat effect. Likewise, if you look at the scale of the working memory axis, the average in the control condition, remember, was about 50. I think it was 54. That's right there. Where's 54 on here? That's like up here. So the threat group is doing worse on both working memory and IQ, yet the relationship between the two of them holds. That doesn't change. So again, that's a difference from moderation analysis, right? The point of this was to say what accounts for the relationship between threat and IQ. So to wrap up, the interpretation of that analysis is full mediation. Why full, not partial, not no mediation? Well, two main reasons. One, the direct effect, the effect of X on Y, went from being significant and strong to being non-significant after we added in the mediator. The second reason, which I sort of skipped over in the results because I'm saving it for the next segment, is there's another test we can do called the Sobel test. And that was the bottom part of my R output that I didn't go over, but we will cover in the next segment. It's called the Sobel test. And we'll look at that in the next segment. The Sobel test was also significant. So we have two pieces of evidence suggesting this was full mediation. So indeed, working memory capacity mediates the effect of stereotype threat on IQ.